Hello again. This is Dr. Rebecca Garris, Colorado School of Mines. I'm making this video for Calculus 2 students to explain the activity from today, which was 11.2, day 1. We are covering this section over 3 days. This was our first day looking at power series. Okay, and we're going to focus on finding the interval and radius of convergence for each of the following power series. And there are 4 for us to look at. All right, so the trick for all of these is to start with the ratio test. So the ratio test says that we calculate R as the limit as k approaches infinity of the absolute value of the k plus 1 term divided by the k term. So the k plus 1 term would be x to the k plus 1 divided by k plus 1 factorial. Instead of dividing by another fraction, I'm going to multiply by the reciprocal. So we'll just have k factorial divided by x to the k. And mostly that's to save space. So, all right, now we can simplify. Remember, k plus 1 factorial is equal to k plus 1 times k minus 1, and so on until we get down to 1. We just keep subtracting 1. So that means that k plus 1 factorial is equal to k plus 1 times k factorial. So that k plus 1 factorial, I'm going to cancel most of those terms with the k factorial in the numerator. And then also the x to the k plus 1 divided by x to the k is only going to leave one value of k there. So this r is equal to the limit as k approaches infinity of x divided by k plus 1. Now really the x can come out because the x doesn't depend on k. So we get x in our absolute values. We don't know if x is positive or negative. And our center is at 0, right? X minus 0 to the k is how we get x to the k. So we get x times the limit as k approaches infinity of 1 over k plus 1, which is this term is going to go to 0, so this whole thing goes to 0. And what do we know about 0? 0 is less than 1 for all, so this ratio, less than 1 for all x, and that means that this power series converges for all x. Okay, so the interval of radius of convergence then is infinity, and the interval of convergence is the interval minus infinity to infinity. And we use rounded brackets on those because, of course, we cannot get to infinity. So that's how we do that one. All right, the second one also has our center at 0. So again, a equals 0, right? Because x minus a to the k is just x to the k, so a must be 0. So we have this one now. We're going to again do the ratio test. R is equal to the limit as k approaches infinity of the absolute value x to the k plus 1 divided by k plus 1 cubed 2 to the k plus 1 times, instead of dividing by the k term, we're just going to multiply by the reciprocal to save some space. So we're going to do times k cubed 2 to the k divided by x to the k. We have to keep our absolute values at least on the x because we never know if x is positive or negative. So this is the limit as k approaches infinity, and let's see what terms we can cancel. So the x to the k plus 1 and the x to the k, all we're going to be left with is a single a single x in the numerator, the 2 to the k in the numerator, and the 2 to the k in the denominator, or 2 to the k plus 1 in the denominator. A k number of factors of 2 is going to cancel, but there's going to be 1 left over in the denominator. So we just get a 2. And then we have k over k plus 1 cubed that we also need to deal with. Okay, so let's pull that absolute value of x over 2 out front because it doesn't depend on k. And then we have the limit as k approaches infinity of the k over k plus 1 cubed, but I'm going to divide everything by k, so I'll just get 1 over 1 plus 1 over k cubed. And that shows that this thing is just going to equal 1. So r equals the absolute value of x over 2, and we know that this has to be less than 1 for the series to converge, the power series. All right, so that's the same as saying the absolute value of x is less than 2. Okay, so what does that mean? That means that x is either, let's see, that means that negative 2 is less than x is less than 2. And this is where it definitely converges. By the ratio test. Okay, so what about at x equals negative 2 and x equals plus 2? We have to do that. We have to test those individually. And I've got enough room here. Okay, so we'll start with x equals minus 2. That means our series goes from k equals 1 to infinity of negative 2 to the k divided by k cubed times 2 to the k. So this is the sum from k equals 1 to infinity of minus 1 to the k, 2 to the k, divided by k cubed, 2 to the k. I'm doing that so that you can see very clearly that the 2 to the k's cancel, and we're just left with the minus 1 left in the numerator. So the sum from k equals 1 to infinity of minus 1 to the k times 1 over k cubed. This is not a p-series, specifically because of that negative 1 to the k, so we're going to use the alternating series test. What do we need to know? We need to know a sub k is equal to 1 over k cubed, and it's greater than 0 and decreasing, and the limit as k approaches infinity of 1 over k cubed equals 0. So series converges by the alternating series test. Okay, so x equals 2. That means, yeah, x equals minus 2 is in the interval of convergence. And I'm just going to highlight that so that we remember that that's an important result. What about when x equals 2? Now we have the sum from k equals 1 to infinity of 2 to the k divided by k cubed times 2 to the k. And this one, we can just simplify right away. Those 2 to the k's cancel, and we're left with 1 over k cubed. And this series converges by the p-series test with p equals 3, which is greater than 1. So that means x equals 2 is in the interval of convergence. Okay, so let's see. That means what we've determined is that the interval of convergence is minus 2 to 2. The radius of convergence is the distance from the center to the end point. The center is at 0, so the radius of convergence equals 2. Oops. And that's how we calculate that. Okay, let's do another one. Cool. Just making sure my notes are right. Okay, so now we have a sum from k equals 4 to infinity of k minus 3 factorial times x minus 2 to the k. So here we have our center at x equals 2, or a equals 2. I'll call it a equals 2. Okay, same thing. We start with the ratio test. R is equal to the limit as k approaches infinity of the absolute value k plus 1 minus 3 factorial x minus 2 to the k plus 1, and then divided by k minus 3 factorial x minus 2 to the k. This is equal to the limit as k approaches infinity. Let's see. We have k plus 1 minus 3 is k minus 2 factorial divided by k minus 3 factorial, and then times x minus 2 to the k plus 1 divided by x minus 2 to the k just leaves us with x minus 2, a single power. All right, so what is, let's see, k minus 2 factorial is equal to k minus 2 times k minus 3 times k minus 4, etc., until I get down to 1. So that means k minus 2 factorial is equal to k minus 2 times k minus 3 factorial. So if I rewrite my ratio, and actually I'm going to pull the absolute value x minus 2 outside, and then I have the limit as k approaches infinity. Remember, I can pull the x minus 2 out because it doesn't depend on k, so it's fine that it comes out. And then inside my limit, I have k minus 2 factorial divided by k minus 3 factorial, and as I showed up above, that just is equal to k minus 2. All right, so what is infinity minus 2? It's still infinity. So this is equal to infinity. It's equal to infinity, really, for all x except x equals 2. Because if x equals 2, the entire series goes to 0. And you're just adding 0. And adding 0 infinite number of times is still just 0. Okay, so r greater than 1 except at x equals 2. That means radius of convergence is 0, and the interval of convergence is x equals 2, or you could say interval of convergence is equal to the set of all numbers equal to 2, which is a very small set. There you go. So that's an example of radius of convergence going to 0. And now this last one, again, we're going to start with the ratio test. Ratio is equal to the limit as k approaches infinity of the k plus 1 term, 2x minus 5 to the k plus 1 divided by k plus 1 times the reciprocal of the k term, k over 2x minus 5 to the k. And we can cancel some terms. This is equal to the limit as k approaches infinity of 2x minus 5 times k over k plus 1. So I'm going to pull that 2x minus 5 out front. And then my limit as k approaches infinity inside, instead of k over k plus 1, I'm going to divide every term by k. So I have 1 over 1 plus 1 over k. K over k plus 1 is indeterminate because it's infinity over infinity. But 1 over 1 plus 1 over k is not indeterminate because it's just 1 over 1 plus 0, which is 1. This is 1. So I get that it's 2x minus 5 in the absolute value, and that has to be less than 1. for the series to converge. Okay, so let's see. I need to test some points. So this means I need to test the points 2x minus 5 equals minus 1 and 2x minus 5 equals plus 1. So what are those? Let's solve the one on the left first. 2x equals 4, so x equals 2. And then the one on the right, I have 2x equals 6, so x equals 3. Okay, so for 2 less than x less than 3, series converges. So I need to test x equals 2 and x equals 3. So at x equals 2, I get the sum from k equals 1 to infinity of 2 times 2, so 4 minus 5 to the k, divided by k. So that's equal to the sum from k equals 1 to infinity of minus 1 to the k times 1 over k. This is an alternating series. So I'll do the alternating series test with a sub k is equal to 1 over k. And that is greater than 0 and decreasing. And the limit as k approaches infinity of 1 over k equals 0. So series converges by AST. And that means that x equals 2 is in interval of convergence. And I will highlight that just to have that easy to find. Now I'm going to test x equals 3. I have my sum from k equals 1 to infinity of 2 times 3, so 6 minus 5 to the k divided by k. That's equal to the sum from k equals 1 to infinity of 1 to the k, which is just 1, so I'm just left with 1 over k. And we know that this series diverges by the p-series test with p equals 1, which is not greater than 1. So that means that x equals 3 is not in the interval of convergence. That's an important thing. So we would say then that the interval of convergence is equal to square bracket 2 comma 3 with a round bracket. And the radius of convergence is half of that, so ROC equals 1/2. Those are my answers. All right, so once again, if you have any questions, please email me, talk to me in class, visit me in office hours. I'm always happy to help you, so let me know. All right, have a good rest of your day.